What's going on, guys? Today we're going to be talking about absolute and conditional convergence in AP Calculus BC. One of the more important concepts when it comes to what's it called? Convergence and divergence within series. So before we start, let's quickly go over what convergence and divergence is. Let's review it. So as we all know, convergence is when, of course, a term is finite and exists, right? Finite and exists. And I apologize for my bad handwriting as I am drawing with a mouse on my computer. Not exactly the greatest idea when it's a manual mouse. But divergence is when said series does not exist or goes to infinity, right? So what we know here is that these are the two different outcomes of a said series as far as what it's going to do, right? So what we do with absolute and conditional convergence is find out whether a certain series is going to converge under all types of conditions or not, right? And basically how we do that is use the absolute value of said series. So we have here a series that, or we have here the exact definition by Matt Libre text, which says that a series that is converges absolutely if that series, the absolute value of that series converges. But if just the series converges and the absolute value of that same series diverges, then it is conditionally convergent. So basically, what we're saying that is that the absolute value of a series needs to be convergent for it to be absolute convergent, and when it is not, there is still a chance that that series could be convergent, but it's not going to be convergent under all different conditions. It's just going to be when that series is by itself. Um, and there are a couple different examples we can do to prove this. I'll give three examples that basically show each different type of way we can each different outcome of the absolute conditional convergence. So the first example we can use, this is the simplest one, is when the series is divergent. So if we were to take something like, say, the series of n plus 1 over, not n, sorry, n plus 1 over 1, all right? If we were to take that series, right, you do 1 plus 1 is equal to, over 1 is equal to 2, right? 2 plus 1 over 1 is equal to 3. 3 plus 1 over 1 is equal to 4, and so on. But what we're seeing is that these numbers gradually increase, and as the series goes on to infinity, that this series is going to go to infinity. Hence, the series by itself is divergent. I'm just going to say, yeah, you get the idea. But now we have to look at the absolute value of this same series. Now, what we know is that if we do the absolute value of the same series and this starts at 1, it's going to still be, the numbers in the series are still going to be the same. 1 plus 1 over 1 is 2. It's still positive 2. 2 plus 1 over 1 is 3. is still 3 if you put it in absolute value. The absolute value of 3 plus 1, that's still 4. Like all these numbers in the series are all positive, right? So they're all going to remain the same. Hence, the absolute value of this series is still approaching infinity, and therefore it diverges. So what we know is that the series of n plus 1 over 1 diverges. So there's nothing that we have to do when it comes to whether we have to determine whether it converges absolutely or converges conditionally. Now, if we want to get to whether something converges conditionally or not, we can give two different examples. The first example, oh shoot, I messed up there. Give me one sec. The first example is 1 over n squared. That's the series. Now, what we know by this series is if you what we know based on our previous knowledge of other, and you might know this from watching other videos of different methods to find out whether a series converges or not, you'll know that 1 over n squared, this is a form of the p-series test. You can use the p-series test to find out whether this converges. And as we know in the p-series test, if something's greater than 1, it's going to converge. 2 is greater than 1. So this series converges. Now we have to look, obviously, at the absolute value of the series. Now, if we do that, we can realize that, all right, let's go 1 over 1 squared, 1 over 2 squared, 1 over 3 squared, right? Absolute value of all of these, you get 1, 1/4, and 1/9. So what we can see with all three of these is that they're gradually approaching 0, hence they are converging. And we also know that 1 over n squared by itself, this series converges. We know that now the absolute value of 1 over n squared is converging. So therefore, this converges absolutely. I'm not going to say the whole thing. That's going to take too long. But you get the idea. Now, there is another example that we can show to kind of prove that when something converges conditionally. And this is probably the trickiest of the bunch, though it's not really too hard to really solve. Let's take this series of -1 to the n, and you'll notice this throughout most series when you're doing these types of problems. Most problems that converge conditionally are a lot of them will end up being alternating series problems. It's just not all alternating series problems will end up like this, but a lot of them do. But let's take -1 to the power of n over the cube root of n squared. All right. So again, we can use other methods, other tests to be able to break down this series. As we know, as we all know, this series is very similar by the direct comparison test to 1 over the cube root. Sorry, that didn't work out very well. The cube root of n squared. which if we can also make into 1 over n to the power of 2/3. Now, based off, oh boy, let me focus that again. Based off this, based off the P series test, again, we know that if something is less than 1, then it di- then it diverges, right? 2/3 is less than 1, so this diverges. Now, let's do the absolute value of this series. We are, here we go. The absolute, now, as we know, with the absolute value of -1n over the cube root of n squared, this becomes 1, all right? But, I'm sorry, technical difficulties, but what I was basically trying to say is that we know that when we know that the absolute value of -1 over n to the cube root over the cube root of n squared, the absolute value of this, we could put it in a series. So let's go -1 to the power of 1 over the cube root of 1, right? So what do we get? We get -1 over 1, and the absolute value of that is 1. Now we could do that same thing with -1 to the power of 2 over the cube root of 4 cubed, and we are going to get, on calculation, I'm doing this on calculator, about 0.75. So what we could see is that 1 to 75, 75 is 0.75 is obviously less than 1. So we know that this this series is slowly approaching 0. So this the absolute value of -1 to the power of n over the cube root of n squared converges. Well, this diverges the regular equation, and this follows the conditional convergence part of the formula that we remember from this. Number 2, if the series a of n converges, but the series absolute value of a of n, the same series, diverges, then said series is conditionally convergent. And since the absolute value of the series is convergent, but the uh, what's it called? The regular series is divergent. This series conditionally converges. So yeah, most of the time you're gonna see a lot of different types of problems that, you know, really the whole key of the problem is just to look at the absolute value. You can use different tests to get to to get to solving those problems. They're not going to be simple at hand, but really what you have to do is just find the test to solve both the absolute value problem and the regular series. Find out whether they are convergent and divergent. If both diverge, then the series itself just diverges. You don't need to say anything else. If both the absolute value and the series by itself converge, it's absolutely convergent. And if the absolute value converges, but the regular series diverges, then you got a conditionally convergent problem. Those are usually the ones that take the longest. But overall, this is a pretty easy concept, especially if you know all your other series tests. So yeah, this is pretty simple once you get to down to the base of it. And yeah, that's it. Thanks.